Alright, so review today, review 7, and it's all about quadrilaterals, and 12, 7, it's Pearl Harbor Day. 18, yeah. Okay, alright, number 1. So let's see, this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decagon, 10 sides. So n is 10, right? And so the sum of all interior angles is just going to be 180 times 10 minus 2. That's my formula, right? N minus 2. So I'm just going to take my calculator, go 180 times 10 minus 2, and I get an answer of 1,440. 1,440. Awesome. Sum of all exterior angles, it doesn't matter what the figure is. It's always 360. And it kind of makes sense because the bigger the figure, the smaller these get until it becomes like almost like a circle, right? So 360 degrees.
Yeah, I have a question.
Yeah, Landon?
On the last one, why did we subtract it by 2?
The formula is 180 times n minus 2, okay? And here's another reason. There's always 2 less triangles. If you drew all the triangles, in a decagon, there would be 8 triangles. That's why it's 180. Okay. So the formula, always n minus 2. Okay. I haven't done that. You're ahead of me. I like that. Okay. Interior angles, so I'm going to do what Annie suggested. I'm going to take the sum, which is 1,440. I know there's 10 of them, right?
Wait.
Yep.
The answer for number 2 is just 360.
Always. Yeah, number 2, the second one, yeah. It's always 360. Always 360.
For any shape?
For any shape. For exterior. For sum of exterior angles. Always, okay?
Wait.
Yeah.
You don't need a square.
Huh?
Is that for a square?
No, that's 90,
Well, what are
90, 90.
exterior angles?
Huh? Exterior. Here, I'll draw one.
Like
There's an exterior angle. There's an exterior angle.
Oh.
There's an exterior angle. Okay? So, and of course, the bigger the figure, the smaller these get, but you get more angles until it becomes like a circle, which is 360, right? Okay, let's do this. Interior angle, so we take our sum and we divide it by 10 because there's 10 angles, and that's 144 degrees. Okay, and individual exterior, boys, let's stop talking. Okay, so it's just 360 is my answer, but I have 10 of them, right? 10 exterior angles. So I divide by 10 and I get 36 degrees, okay? Same kind of problem on Monday. The only difference is it's just a different figure, okay? That's all. Pretty easy.
You like the same test, kind of?
Yeah. Okay, number 2, and I'm probably going to do it on a separate sheet of paper. So a polygon has a sum of the interior angles of 900 degrees. What is this polygon? So my formula, and I'll do 2 on a separate sheet of paper. My formula is 180 times n minus 2, but this formula gave me an answer of 900. So if I want to find out how many sides it has, I'm just going to solve for n. So, to solve, first step, well, I could do that. I could, and there's nothing wrong with distributing first. I'm just going to divide. Yeah, it's just faster to just divide first. So I'm going to go 900 divided by 180, and I get 5. So I get n minus 2 equals 5. Plus 2 plus 2, n is equal to 7. Or a 7-sided figure, which is a septagon or a heptagon. Doesn't really matter what you call it, okay? Okay, number 3. No, I'll wait. I'll wait for you. Sure. 4x plus 13.
Wait, hold up, but we found it. So then we have to find... Wait, did we just do number... Yes, we did.
It's okay, don't worry about it. I'll wait for you.
Yeah, wait for me too.
I will. I'll wait for you, Joe. Yeah. Gotcha, Jay. Okay, I'll wait for you guys and we'll do number 3, okay? Slide it up. Okay. All right, it's parallelogram. So what I know is opposite sides are equal. So I'm going to go for these 2 because those are both x's. I'm going to wait on the y because I've got y and x. So I want to do the x's first. So I'm just going to go 4x plus 13 equals 5x minus 12. And I'm just going to solve for x. Those 2 are equal, opposite angles of a parallelogram or congruent. Minus 4x minus 4x. 13 equals a 1x minus 12. Okay. I need to add 12 plus 12 plus 12. X is equal to 25. Now, what's the question? The question says find the value of x. Okay, I don't need any more than just that. I don't need to plug it back in because it just says find x. And then find y. So find x, I've got it. And then if I want to find y, I'm going to take y is sitting right here, but I need y to be equal to something. So I will actually plug the 25 in to here. And that'll help me get what y is, because these two angles are equal. So if I plug it in, I'm going to go, okay, 3 times my 25 minus 8 is going to equal my 4y plus 7. So what I did is put my 25 in for x into this angle. And I did that because these two angles are equal. And that'll be able to find y. So 3 times 25 is 75 minus 8, 4y plus 7, right? Let's see, 75 minus 8 is 67 equals 4y plus 7. And I'm going to go minus 7 minus 7, 60 equals 4y. Divide by 4, and I think I get 15. So I've got x, and I have y. Okay. Need some graph paper for the next one, so I'm going to grab some graph paper. So, I don't know if anybody else needs graph paper. You guys can pass it around. Anybody need graph paper? Here, okay, just pass that around, okay? Okay, so I'm going to graph so let's see here. Number 4. Negative 3, negative 2. A. Negative 1, 1. B. 4, 1. C. And find the fourth point. Okay? There are technically 3 correct answers, but the easiest ones, yeah. So there are technically, so the one you're probably going to get is there. There's also, believe it or not, one up here. There could also be one way over here. But you only need just one of them. The easiest one is right here at 2, negative 2. Okay? Sure. So Zoe, yeah, I can't, here, let me put it this way, okay? So up 1 over 1, right? Straight across, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That would make my parallelogram, wouldn't it? Okay. All right, number 5. All right. I'll do 5 on a separate sheet of paper. Okay, slide this away. All right, 5 is a rhombus. If it's a rhombus, I know this is perpendicular. That's a big key right there. If it's a rhombus, that's perpendicular. This is 25 degrees, okay? Now, rhombus, there's a couple of things that happen in a rhombus that are kind of nice, okay? First of all, it does 2 things. It will bisect the angles. Well, if it bisects the angles, that's 25, and that's 25. Since it's a parallelogram, opposite angles are equal. 25 and 25. Okay? Now, to get this angle right here, I'm just going to look at it as a right triangle. Okay? So I see a right triangle right there. You guys see my right triangle, right? And in a right triangle, I can find out what this is by just going 90 minus 25 should give me that angle right there. 90 minus 25 is 65 degrees. So this angle is 65. In a rhombus, we bisected our angle, so that's also 65. I know that opposite angles in a rhombus are equal, so that's 65, and that's
Mr.
also
Davis,
65. Yeah.
Did you say that the one that
that
Can
goes
you go up a little bit?
that's shorter doesn't exactly bisect the
In a
diagonal.
kite, absolutely. In a kite, yes. But this isn't a kite. You're
This
completely
is a
right.
rhombus.
It's a rhombus.
My brain is doing.
That's okay. Don't worry about it. You're totally correct with a kite. Okay. All right. Let's take a look at 6. Okay. I will. Am I going too fast?
Can I just
Yeah.
borrow
Sure.
the review sheet out right now?
Yeah. Okay.
Trying to make it
We need to get the sides.
Oh, the sides. We can't give the sides because I didn't give you any sides. So you know what? Next time I do this worksheet, I will put some sides in there.
Good, so no sides.
You want to put some sides in there?
No.
Okay.
Wait, are we gonna do on the test?
Maybe.
Then yes. We should do it. Yes.
Okay, let's say this side is 10.
I don't.
It's a rhombus.
I wasn't here yet.
It's a rhombus. They're all 10, right? If it's 10, they're all 10. You guys agree with that?
One, right?
Okay.
It's good to know.
Let's just say real quickly that this diagonal is 3.
Shut up. The other one's two.
The other one's 3, right? Let's say this is 7. The other one's 7. Okay. All right. Number 6. Ready for 6?
Or you can also.
Okay. Okay, it is a trapezoid. And what I know is the first base is 2x minus 2. The second base is 3x plus 12. And the mid segment's 15. So if we want to find the sides, let's find x. So base 1 plus base 2 divided by 2 equals mid segment. So base 1,
Well, the big segment is already 15.
but we need to find the lengths of these two. Okay, plus the other base divided by 2 equals 15. So we set it up. What we need to do is just basically solve for x.
Wait, they're the same? Oh, just kidding.
Okay, we need to solve for x and then plug it back in. So we got to find x, plug it back in. So I've got base 1 plus base 2 divided by 2 equals 15. Okay, so 5x plus 10 divided by 2 equals 15.
Wait, we
Okay.
should have five.
Okay, it's all good. Okay, since I really can't divide 5, I could, I get 2.5. I'm just going to multiply by 2. Makes it easier. I'll just multiply it by 2. That way I don't have any decimals or fractions, which I don't want. So I'd rather go 5x plus 10 equals 30, right? Multiply by 2.
Wait.
Just multiply it by 2. Times by 2, times by 2. Minus 10, 5x equals 20. X equals 4. Now that's not our answer because what we want to do is plug that 4 back in because we need the sides. So I'm going to go back to my figure and we're going to plug in 4, right? X equals 4. So we're going to go 2 times 4 minus 2, which is 8 minus 2. 8 minus 2, which is 6. So the top base is 6.
Okay, can you go back a step?
Yep. So I plug 4 in,
Oh my god.
right? And
Wait,
2
wait,
times
wait.
4 is 8.
You plugged
4. Okay, x is 4, right?
Ow! Okay, what? How'd you get the answer for
Wait,
that?
can you go back up a little bit?
Hold on, one thing at a time. Got x is 4, right? Did you get 4?
Because, wait, how did you get 4?
Divide by 5, divide by 5.
Oh, the minus 10, minus 10.
Okay, right. I'm going to bring it up in a second. Okay. And then, Lana, what's got 4?
Wait,
Jake?
minus 10?
You're good. Just you can keep showing.
Right.
Okay, actually, I'm gonna get this wrong. You can.
I will give you this when I'm done. Okay. All right, hold
No,
on.
you don't have to get. I'm just gonna get this wrong. In the test.
Okay, you ready? Jay?
Yeah.
Okay, now if I'm going to plug the 4 into here, 3 times, plug 4 right in here, right? I get 12 plus 12 equals 24. Okay, how's that?
Oh, hold up.
Oh well.
Because I didn't know.
Okay.
Okay, you ready for 7?
Yeah. Oh,
Okay, I'll zip this away in a second. Okay. All right, find each side and each angle. So here we go. Okay, Caleb, it's a kite.
90.
It is a kite.
So 90's right. Yes, 90 is really important to put the 90 right there. Thank you. That's going to help. So here's what I know. This angle A got bisected, so this is also 42, okay? I know that this 68 is equal to this 68 over here, because these are equal angles, 68, okay? Now, to tackle this problem a little further, what I'm going to do is look at a right triangle. Okay, so I've got a right triangle here, and I got another right triangle here. I want to look at both of these, okay? So, first of all, 42, 90, and whatever from 180, give this one. So, or better yet, since the 90 is there, I can just say, okay, for angle B, or this angle right there, I'm just going to go 90 minus 42, which would give me 48. Does that make sense? These two angles have to add up to 90, because in a triangle it's 180, but 90 has already been used up, right? So these two have to add up to 90, which makes 48. Okay, so this angle right here is 48, okay? Which means this angle is 48. Okay, now I'm going to look at this other triangle here. Same thing. These two angles have to add up to 90. They're complementary. So to get this angle right here, I'm just going to go 90 minus 68, which is what, a 22? I guess 22, which means this angle is 22, okay? All right, there you go. And as far as sides, these two sides are equal, right? And these two sides are equal. So you might see that tomorrow or Monday, okay? Now, finally, number 8. To prove it's an isosceles trapezoid, so I'm going to graph it, and I'll go slowly through it, okay? All right, slide it up. Okay, number 8. All right. Okay, let's graph this the best we can. I've got negative 1, 2, 3, 4, 5, 2. There's A. Negative 5, 1, 2, 3, 4, 5, 6 is B. Negative 1, 6 is C. 1, 2, 3, 4. And 2, negative 1 is D. Now, it says it's an isosceles trapezoid, so let me go ahead and see if I can find it. Let me draw it in, okay? Okay, looks like it's a kite, doesn't it? I don't think it's a trapezoid at all. I think it's a kite. So let's cross that off. There's something I got to fix. How about the fact it's prove it's a kite? Okay. Well, let's change that problem. So if it's a kite, what do we know? What's the definition of a kite? What's the definition of a kite?
Diagonals bisect the
Well, that's not the definition. That's a characteristic, and you're totally correct on your characteristic. But what makes a kite is that this side is equal to this side, and this side is equal to that side. That's the definition of a kite. So what we're going to do then is just take a look at the length. So is AB equal to BC? Sure looks like it, doesn't it? So let's figure out what the length really is. Well, this is easy because you can just count. So if I count this, I've got 1, 2, 3, 4 is equal to 1, 2, 3, 4. 4 is equal to 4, right? Okay. Now, we haven't proven everything because now I need to know is, this is D here, isn't it? Is CD equal to AD? Well, that one's not so easy to find. We have to prove it. We're going to prove it. So what I'm going to do is create a right triangle and use Pythagoras Theorem. So first of all, if I want to find the length of AD, the easiest way to do it is to make a right triangle and go a squared plus b squared equals c squared, and that will give me the length of this. Okay, again, to get the length of this, the easiest way is to create a right triangle and use a squared plus b squared equals c squared. So, and I'll do the same thing with CD. I'll create a right triangle right there. And again, to find the length of CD, I'll use a squared plus b squared equals c squared. All right, so first of all, CD. Looks like 1, 2, 3, 4, 5, 6, 7. So 7 squared plus 1, 2, 3 squared equals, c squared or CD squared. Okay, that's 49 plus 9, which is a 58, equals c squared. So I'll take the square root of 58. Okay, so the answer is square root of 58. And I could use a calculator and get a decimal, but I'm going to leave it as the square root of 58 because that's a length. Okay, so now I'm going to go and say this length here is the square root of 58. All right. Well, what's the length of AD? Hopefully the same. And if it is the same, we've proven it. So how do I find out the length of AD? Again, by Pythagoras Theorem. So if I set this up, 1, 2, 3, 3 squared, plus 1, 2, 3, 4, 5, 6, 7 squared, okay, equals c squared. Same thing. I'm going to get a 9 plus a 49. A 58 equals c squared, square root of 58. So what I've done is proven it. I have absolutely proven it because
You got what? Yeah. Can I find my video?
I've got the...
On like counting over.
You got what?
I must have.
Okay. So the lengths are the same, and the lengths are the same, which means it has to be a kite. There's your proof. Okay. All right. I'm going to pause this right here.